Right, question 17 is a really prickly question, and the easiest way to approach it is to break it down into its separate parts. It is scary to look at, and it does get quite intimidating when you get halfway through and you kind of feel like you want to give up. If 4 marks are out of reach for this question, then just aim to get some of them, okay? But try and hang on in through this question. So a cylinder just fits inside a hollow cube with sides of length m. Before I do anything else, I'm going to identify that I'm dealing with a cylinder and a cube here, and I'm just going to make a little sketch to myself that the cylinder is this shape, and I'm going to put any dimensions of that cylinder on that I need. So there's the cylinder. I know that that part, and that's the radius, that's m/2, and I can see from the diagram that the length of that cylinder is m. So there's my cylinder as a separate. I've also got a cube that's been mentioned, so I'll sketch myself a little cube, and the cube has all lengths of m. So that's m, that's m, and that's m, because in a cube they're all the same length. Right, read on. Oh, before I read on, actually, because this question is about fitting something inside, my brain is ticking over reading this, thinking volume questions are usually about fitting stuff inside. If you have things that, or if you have a question that is sometimes asking you to cover something, that's probably going to be an area question. If you have something that's going to surround or enclose, like a fence, that's probably going to be a length and perimeter question. And if you have something that's inside or looking to fill, then that's going to be a volume question. So this is talking about fitting inside something. I reckon it's volume. Let's read on. So the radius of the cylinder is m/2. Okay, I've got that. The height of the cylinder is m. The ratio, now remember ratio is something written ... The ratio of the volume of the cube, so they've mentioned the cube first, so the ratio of the volume of the cube to the volume of the cylinder is given by volume of cube to volume of cylinder. Okay, so they gave us that anyway. And they've said that that's k to pi. All right. They've then gone on to say that k is a number, so that's just a number. Find the value of k. You must show all of your working. Right. Well, it's at this point where things started to get really scary, talking about these ratios. Up until that point, we were talking about filling something, and they've even mentioned the word volume. So there's probably some method marks in this for me by showing that I can find the volume of the easiest first, which is going to be the cube. So the volume of the cube. And we talked about volume earlier in one of the earlier questions. The volume of any kind of prism is the area of the volume of any prism is the area of the cross section times by its depth. So the volume of this cube is going to be m times by the other m. So the volume of this cube is m cubed. Now I'm going to consider the volume of the cylinder. Notice how I'm writing words out and laying my working out in case there are communication and organisation marks, alright? And I am still checking all my spellings. So volume of a cylinder, right? Well, that seems like it'll be difficult. However, you need to remember that volume is equal to the area of the cross section times by the depth. So let's look at the cylinder up here. This is the cross section, because I'd have to put it in a slicing machine that way. And so if I find the area of this circle and multiply it by m, that's going to give me the volume. So the volume of the cylinder, well, we'll do area of circle first, and that's pi times r squared. So pi times the radius they gave us was m over 2. Because I'm substituting a value in, I'm using a bracket. So pi times m over 2 squared. Now I'm going to get rid of these brackets first of all, and because the squared is on the outside, it means both terms inside here have to be squared. So that is equal to pi times m squared over 2 squared, which is 4. And then I'll combine that just to give me pi m squared over 4. So that's the area of the cross section, which is the circle. So the volume of the cylinder is going to be pi m squared over 4 times by the depth, which is m. So the volume of the cylinder is actually going to be pi m cubed over 4. Now I've got the volume of the cube and the volume of the cylinder, I can gain some marks by putting them into the ratio that they've discussed here, because remember they've just told me volume of cube to volume of cylinder. Now this is what I think the volume of my cube is, and I very clearly said that this is what I think the volume of my cylinder is. So I'm going to write that m cubed, and then the ratio sign, and then I'm going to write the volume of the cylinder, which is pi m cubed over 4. So I've written it out in the ratio. Okay, I've run out of room on this page, so I'm just going to squeeze my work in up here. I think on the actual paper you get a whole other page. So start again with my formula, which was my ratio, which was m cubed to pi m cubed over 4. Right, now the ultimate goal here is to get k down to just a number, and so that's this m cubed. I need to get it down to just a number. At the moment it's an m cubed, and remember with algebra this is actually 1m cubed, and that would be 1 pi m cubed over 4. I'm going to leave that there in green for now. It just makes it a little easier to image what's going on. Now with ratios, if I was to double this part of the ratio and have 2m cubed, I'd have to double that side of the ratio, so I'd end up with 2 pi m cubed over 4. If I was to times it by 10, I'd have to times them both by 10. However, I want to get this down to just a number, so I'm going to divide by m and divide by m. That's going to take me down to an m squared there, and dividing this by m is going to give me pi m squared over 4. Then I'm going to take it down another power of m. So m squared divided by m is m. Pi m squared over 4 is going to be cancelled down to pi m over 4. Remembering that's 1m squared, that's 1. That's 1m, that's 1 pi m over 4. Now, in order to get that as just a number, if I divide it by another m, on both sides of course, that's going to leave me with 1 to pi over 4. Alright, I'm getting somewhere. This is now a number, which is what they want. However, they wanted this part to be just pi, and at the moment this is pi divided by 4. So what I need to do here is get rid of the divide 4. The opposite of dividing 4 is timesing by 4, so I'm going to do that on both sides, because that will cancel that 4 down, and that will leave me with 4 to pi. And that is in the form that they wanted. And the hard work is done, so I'm going to make sure I don't miss out the opportunity to say k is equal to 4, because it would be 4 to pi. So a really difficult question, that one, but let's have a little look through the mark scheme step by step to see what is achievable without getting into all the complicated issues of the ratio. So you get 1 mark for seeing that you can calculate the volume of any of these. Okay, that's 1 mark. And you can all calculate the volume of a cuboid. You can do this. You should also be able to calculate the volume of a cylinder. The fact that it's got pi's and m's in it makes no difference. The method is still the same. You get a second mark then for sight of, or for seeing the volume of your cylinder. So that's there. And in fact, you get 1 mark for that part, and the second mark for the volume. So you get 1 mark for showing that times by m. So now we're up to 3 marks. The 4th mark is then for cancelling all this down and being left with the actual answer, which is k equals 4. Okay, this is the most clear way I can explain that. Feel free, if you want to come and discuss it with me, then feel free to do that.